Hey everyone, Mr. Skelton back at it here, lesson 3, unit 3, and today we're going to be graphing parabolas in vertex form. My printer kind of acted up here, so I got this line running right through it. So I'm going to rewrite it for you. Okay, so graphing parabolas in vertex form. This is called vertex form. All right. Yesterday, or in lesson 2, we talked about standard form, and hopefully you remember standard form. That's y equals ax squared plus bx plus c. So you got to know those two forms. By the end of the day, by the end of this lesson, this video, I'm going to ask you to be able to write something to write something in standard form from vertex form, and vertex form to standard form, and go back and forth. That's going to be one of the goals of today's lesson. So you're going to familiarize yourself with that. Now, a lot of this stuff today that we do is going to be review because we have already graphed some of these before. These have our shifts, and we'll talk a little bit more detail about them, but this is going to be, a lot of this stuff will be review for you, and so that should be good. So let's just jump right into it. I have a question, a really good question, which is kind of review. And you're going to see this on homeworks and quizzes and tests, but I wanted to kind of talk about it and go into a little bit more detail. It says, suppose a baseball is hit in the air. The height of the ball can be modeled with the following equation. All right, so we have something like this. There's our ball that's in the air. You can see it's a negative a value, so it is going to be a frowny face, right? It's going to be opening upside down. It's a quadratic, and so we have our quadratic here. It says, how long will it take for the ball to reach its highest point? Now, honestly, you know, a lot of students are going to memorize how to do certain problems, but if you just think about this for a second and look for some key words, it should help you think about what you're going to use. Highest point. What does that mean? When I read this question, how long will it take for the ball to reach its highest point, I immediately think, oh, I need to find the vertex, right? I need to find this point right there, because that's going to be the highest point that the ball reached. Well, what did we do in lesson 2, right? Really lesson 2, which was our standard form stuff. How did we find that highest point? We found the vertex. Well, how did we do that? Remember that x equals negative b over 2a. That's how we find our x value of the vertex, okay? So what would that be? Well, that's going to give us negative 96 over 2 times our a value, which is negative 16, so we get negative 96 over negative 32. Take out the old calculator, right? 96 divided by 32, you can probably do this mentally, and you should get 3. So we get x equals 3. Now, what does that mean? Well, if we're looking at this equation here, if I make a graph, right? What's on the bottom usually? Usually it's time, okay? Where if we're talking about a baseball, we're talking about usually how high it is. We want to find its highest point, so height. So what does this x equals 3 mean? Or if you look at this equation, what is the x value representing? It's representing time. So it took the ball 1, 2, 3, my graph's off a little bit, but it took 3 seconds for that baseball to reach its maximum height. All right? So when I look at this equation, I know that my variables represent these two items, time and height. So part 2 says, well, how high will the ball get? So what am I asking you to find? I'm asking you to find the actual height of the ball. I'm asking you to find y. So you need to take this 3 and plug it back into the original equation, where x represents time, to find your y, which represents height. So we go y equals negative 16, 3 squared plus 96 times 3 plus 3. You take out your calculator, make sure you do exponents first. So negative 16 times 9 is negative 144 plus 96 times 3. It's going to give me 288 plus 3. And if I do that math real quick, it's going to give me 144 plus 3, which is 147. So my y, or my height, is 147. So this point right here is 3, 147. And what does that mean? It means it took 3 seconds to get to its highest point, and it was 147 feet high. All right? Great question for quizzes and tests. Again, if you look for key points, highest point means vertex, and you go down the vertex rule. All right, let's get rocking and rolling into what we're going to talk about today. So, graphing in vertex form, and again, this is review, but I'm going to try to explain it in a little bit greater detail for you so you have a little bit better understanding. So it says, let's start with this right here, which is y equals x squared. So I'm going to make it just a quick t-chart for y equals x squared. I'm going to plug in a 0, I'd get a 0. If I plugged in a 1, I'd get a 1. If I plug in a negative 1, I'd also get a 1, a 2, and I get a 4, a negative 2, and I also get 4, right? That's your 0, 0, 1, 1, 1, 1, 2, and 4, which would be here, and negative 2 and 4, which would be here, right? And this would be our parabola, okay? So that's your basic equation. This is, again, this is vertex form that we're looking at right here. This is vertex form. And so we want to talk about what the A value does. Now I want you to think about this for a second, and we've talked about this. What does your A value do? Your A value either stretches it or it shrinks it. Now think about that. If I had a 2 here for A, okay, let's say A equaled 2. Well, all of these numbers right here would be multiplied by 2. If I plugged in my 2 for x, right, I got 2 squared, which is 4, but then I have to multiply that 2, I'd get 8. So everything is multiplied. And so we talked about this before. If your A value is larger than 1, that's going to stretch. Okay? That's going to stretch your points. I guess it's the absolute value of A, right? Absolute value of A. If your absolute value of A is less than 1, that's going to shrink. Right? If we had our A value being a 1/2, that would cut this 4 in half, and it would make our graph shrink. We talked about this in Unit 1. So that's your A value. Your A value is going to stretch and shrink. What else does your A value do? The other thing that you need to be aware of for your A value, if your A value is positive, that means you're going to get a parabola that opens up, and your A value is negative, that means your parabola will open down. So your A value does two things. Tells you whether it's going to open up or down, and then tells you whether it's going to stretch your points or it's going to shrink your points. And again, that's from the first part of Unit 1. What if there's a K value added to this? So envision that my A value was 1, but all these points here, let's say my K value was a 2. Well, what would happen? Well, you'd get, if I plugged in a 2 for x, I'd get 2 squared is 4, my A value is 1, and I'd get 4, and then plus 2, which would be 6. So at 2, 4 now is 2, 6. So what's happening? Every point, this point would be here normally, but if I had the plus k, that now is up 2 units. If I add 2 units to the 1, that means it's up 2 units here. So your k value moves things up or down. Okay? So if you have a plus 2, then it's going to move it up 2. If this was a minus 3, every point would be moved down 3 units. So your k value moves up and down. Now, down at this second slide, we're going to focus more on what the h value does. So again, we're talking vertex form. Vertex form is here. We've already discussed our A value. We've already discussed our K value, moving things up and down. So now let's talk H. So again, if we take our y equals x squared graph, which is here, 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 2 and 4, negative 2 and 4, I have this parabola here. And what what would happen if, let's say, I'm just going to make one up here. Let's go x minus 2 squared. Okay? And so what I want to do first is I want to try to zero out this equation. And the way I would do that is I'd plug in a 2 for x, right? 2 minus 2 is 0. 0 squared would be 0, and I'd get 2, 0, which would be right here. Okay? And so now I'm going to pick a point to the right and to the left of my new point of this equation here. So let's pick a 3. If I pick a 3, 3 minus 2 is 1. 1 squared is 1. So at 3, 1 would be here. And let's go positive 1. 1 minus 2 is negative 1. Negative 1 squared is still 1. So what happened, and I'll kind of highlight this for you here, if it doesn't bleed all over the place. What happened to each of the 3 original points? Original point here, here, and here. What happened to those 3? They were slid to the right 2 units. Now, even though this is a minus sign, I know it throws people off a little bit, but it slid everything to the right 2 units because I need to, in order to zero out or have that 0 starting spot, everything would slide to the right 2 units. So, what does our h value do? Our h value right here moves the graph or moves your points right or left. Now, Remember, if it's a -2, a lot of students, just to remember, is that you're going to slide to the right 2. If I had something like y equals x plus 4 quantity squared, that's going to shift our graph to the left 4 units, because you'd have to plug in a -4 to get a 0 for your y, okay? And so that's why it'd be left 4. All right, let's keep moving here. So now we're actually going to graph some of these, and again, a lot of this is review for you from Unit 1, but it's good to kind of go over it. So let's take a look. It says graph the following equations. When I look at this, the first thing I do is, the first thing I want to identify is what type of function is it. This is a quadratic. I see this squared. Okay, it's in vertex form, which is good to know. So I'm going to put a couple things down on paper. This is what I would do. The first thing I'm going to do is identify my a value. It is a 2 and it's positive, so I know that this parabola is going to open up. I know because this is a 2 that my graph is going to be skinnier. It's going to get stretched a little bit because my a value is above 1. And then what I want to do is identify my h and my k. One thing I probably forgot to mention here, which I probably should have done right from the get-go, is our hk is your vertex. Your hk is your vertex, all right? And so when I come back over to this graph right here, next thing I'm going to do is identify my vertex. So my vertex here is going to be -1, -3. That's going to be my vertex for this equation right here. I'm going to shift it to the left 1 to zero this out, and then down 3. So to the left 1 and down 3. That's my vertex right there. I always put in my axis of symmetry. So my axis of symmetry, and I will ask for that, would be x equals -1. And then I would proceed to make my t-chart, okay? So if I make my t-chart here again, if my vertex is -1 and 3, I want to pick points to the right and to the left of my vertex. So I would pick a 0 here. If I plug in a 0, 0 plus 1 is 1, squared is 1, times 2 is 2, 2 minus 3 is -1. So I get 0 and -1, which would be right here. And then because, remember, parabolas are symmetric, if I'm 1 unit to the right here, then it's 1 unit to the left there. I may pick a point like a +1, okay, which would be 2 units to the right of my vertex. So 1 plus 1 is 2, 2 squared is 4, 4 times 2 is 8, 8 minus 3 is 5, so at 1, I'm up at 5. So if 2 units, 2 units to the right, then I need to go 1, 2 units to the left, and there is my parabola right here. Again, 5 points gives you a really nice, accurate parabola, okay? Go ahead and hit pause, try the second one here, number 2, and then check back with me, see if you got it right. Okay. So the first thing I'm going to do on this one is I'm going to locate my a value. I know right away that this parabola is going to open down. The second thing I'm going to do is write down what my vertex is. My vertex is going to be 2, 4, okay? And so I'm going to write that down, which would be 2, 4, 1, 2, 3, 4, which is 2, 4 right there. I'm going to write in my axis of symmetry. Draw in my axis of symmetry. I always write the equation as well, so that's going to be x equals 2. Remember, it's a vertical line. And then I'm going to proceed to make my t-chart, and 2, 4 is my vertex. So I'm going to pick a point to the right and to the left. So I'm going to pick +1. 1 minus 2 is -1. -1 squared is 1. Negative out in front turns that into a -1. Plus 4 makes 3. So 1 and 3 would be here. And then symmetry puts my other point there, and I'll pick one more point. I'll go 2 units to the left, which would put me at 0. If I plug in a 0, 0 minus 2 is -2. -2 squared is +4, but then the negative out front makes it -4 plus 4, which is 0. So I actually get 0, 0. So 2 units, 1, 2. Then I got to go 2 units, 1, 2. And here is my parabola for this problem. Okay? Very good. All right. This is probably new for you. It says write an equation in vertex form. It says write an equation in vertex form of the parabola with the vertex. So this is my h and this is my k, with a vertex that goes through the point 4, 5. So this is my x and my y. So the first thing I want to do is I want to write down my vertex form. Excuse the bell there. Okay, so there's my vertex form equation. And what I'm going to do now is I'm going to plug in my h, my k, my x and my y, and I'm going to use substitution, and wherever I see those letters represented in my vertex form equation, I'm going to do that. In other words, the only letter that I don't have is a. Now I know you can see the answer right here, but here's what we want to do. My negative 5 would be substituted in for y. My whole point is to solve for a here. My x is a 4, minus my h value is 2. Now don't put plus 2 here. Remember, your vertex form is always a subtraction sign. The only time that's going to change to a plus sign is if your h value is negative. So this is just 2, okay, squared plus k, which is 3. And I'm going to solve this for a. So I get negative 5 equals a. 4 minus 2 is 2. 2 squared is 4 is what I get there, plus 3. So I'm going to subtract 3 from both sides. I get negative 8 basically equals 4a. Divide by 4, and a equals negative 2. Once I get my a value, then I'm going to take that and write my answer as y equals negative 2 times x minus 2 squared plus 3. I substitute my h and my k in, and that is my vertex form. Okay? Moving on to the last page here. This is kind of what I talked about at the beginning, where we have to do some converting between standard and vertex form. So I'm going to ask you to go from standard form to vertex form and vice versa, vertex form to standard form. So let's take a look. It says rewrite the following in vertex form. Well, in my mind, again, let's not memorize, let's do a little bit of thinking here. Vertex form, what do we need? What do you need in vertex form? You need a vertex, right? That's the most important thing. So when I look at this, which is in standard form, I need to get the vertex. Well, how do you do that? You should hopefully recall that negative b over 2a gives you the x-coordinate of the vertex. So let's substitute in. I get a negative, I plug in a negative 4 in for b over 2 times 1, so that gives me positive 4 over 2, which is 2. So that means right now my vertex is 2 comma something. What is that other value? What's my y value? Well, I take this 2 and I plug it back in for x. So I'd get y equals 2 squared minus 4 times 2 plus 6, which gives me 4 minus 8 plus 6, negative 4 plus 6, which is 2. So y equals 2. So my vertex is 2 comma 2. That is my h and that is my k. All right. Now, when you go to write this in vertex form, remember vertex form is y equals a, x minus h quantity squared plus k. What's the one thing I'm missing? I got my h and my k, I don't have my a. But you do have your a value right here. There's no number listed there, but what's really there? A. Remember that your a value is 1 here, your b value would be negative 4, and your c value is 6. So you actually do have your a value, so the answer to this is 1. Now you don't need to put a 1 there, but it's okay if you do. X minus 2, that's your h value, squared plus 2. That is your answer. The bottom part of the slide says, can you go back if that was the question? Meaning, can you take this answer and turn it back into standard form? The answer to that question is, of course. What you would do is just multiply this out, right? So you have x minus 2 squared, which is really x minus 2 times x minus 2, and then plus 2. So this becomes x, you just FOIL, x squared minus 2x minus 2x plus 4, x squared minus 4x plus 4, and then plus the 2. So you get x squared minus 4x plus 6. And that is the same thing as what we started with right there. All right? And that's how you kind of go back and forth from vertex to standard. Now, very last slide. This says rewrite this equation in standard form. I just kind of did that above, so why don't you hit pause, try this one, and see what you come up with. Okay, so when students look at this, the first thing they're not sure about is what to do with this negative x. My advice to you would be to do this part first, okay? I would square this binomial, and then I would go back and multiply a negative x by every term that you have, and then at the end add 4. Let me show you what I mean. I would go x plus 2 times x plus 2 first and get that answer. Let's FOIL it. That's going to give me x squared plus 2x, which is 4x, and then 2 times 2 would be 4. And then with that, I still have this negative x hanging out in front, right? So I just basically turned this x plus 2 quantity squared into this, and then I have to multiply this through, so I get a negative x to the third. I'm just distributing here. Negative x times 4x would be negative 4x squared minus 4x, and then I have this plus 4 left over, which would be that right there. And let's see, what am I missing here? I did something incorrect, maybe. What did I do? X squared, 4x, 4, negative x to the third. Let's see. I don't think this is the correct answer, unless I'm doing something not awful here. Let me just double check this. So x plus 2, x plus 2, x squared plus 2x plus 2x plus 4. So that gives me x squared plus 4x plus 4. And I have to times all that by a negative x, which gives me negative x to the third minus 4x squared minus 4x. And then I just have this plus 4 hanging out, so I should just get y equals negative x to the third minus 4x squared minus 4x plus 4. That should be the winner. I don't know why that answer is there, unless I'm doing something completely wrong, but I don't think I am. So, standard form, okay? That's all you're going to have to do on the assignment. When you come to class for assignment 3, you're going to be graphing, and then you're really going to be going back and forth between vertex form and standard form. Okay? See you in class.